Okay, so 6 special quadrilaterals. Guys, in the heading of your notes, will you put a box around this word? Big time we're identifying today. So we're looking at quadrilaterals, four-sided shapes. And we're going to identify which one it is. Keep this one, will you just draw an arrow to it? And then a frowny face, and then a happy face. I'll tell you what. So proving that quadrilaterals are a special type of quadrilateral, that's what we've been doing on the warm-ups, where you've got to graph it and then show slope or distance formula. Now, as a teacher, when I teach geometry, and then the geometry students take their CRT, I take that data and I go through and I see which ones are the most missed questions. Guess what? These ones are the most missed questions. It really boggles my mind because as a teacher, I like to be better the next year, right? So every single year I try to do more and more and more of the same stuff so that those students can improve. Yes, they're improving, and here's what I think is the bottom line for these ones. We get tired of them. So it's like, oh, these problems, and it's a multiple choice test, so people are just like, probably this one. So they just guess. Guys, CRTs, can you take as long as you want on them? Yeah, take your time. Graph it, show the slope, show the distance formula. Might as well get those ones right. I think you guys understand how to do them. It's just take a deep breath, crank it out, and finish them. Okay. All right. We've got three things. Underline what's going on. So we've got to identify which quadrilaterals have, right here, underline this, perpendicular diagonals. Hint, how many of them are there? There's 3 of them. So you got to think, what have we talked about so far? Can you think of 3 shapes that have perpendicular diagonals? Write it down first, and then we'll talk about it. Right here in this blank space is for a sketch. So if you can think of one, write it down and then sketch it. Take your time. Try to think of 3. With your fingers, show me how many you came up with. 1, 2, 3. How many did you find? Okay, now they have to be diagonal every single time. Does anybody have 1? 1, I know the diagonals are perpendicular in this quadrilateral. Callie, give me 1. Square, definitely. Okay, square is kind of a hint for another one. Something else could be a square. You got another one, Tyler? Rhombus. We've got square and rhombus. Those always have perpendicular diagonals. We've got one where that every single time they're perpendicular. Christian, you got it? Kite. Somebody talked about last week, right? Where people in the park, they're flying their kites. Usually on the back, they've got a frame, and it's in a letter T. That's what you hold on to. So if you need help with your sketches, rhombus, square. Now we're talking about diagonals. It wouldn't hurt to add in what's going on with the sides. There's tons of other stuff going on, but we might as well just add real quick. The sides in a rhombus, because sides in a rhombus are always equal. So let's add in our congruent symbols. Is a rhombus a parallelogram? Yes. Ellie, question, comment?
Those are the only ones, right, with equal diagonals?
No, perpendicular diagonals. They're the only ones that equal 90 degrees. Great question. Okay, square. What about the sides in a square? Always equal, right? Okay, and a kite. Okay, then, pause. Is a square a parallelogram? Definitely. All right, is a kite a parallelogram? Are opposite sides congruent? Do you remember the one word that says which type of sides are congruent? Callie, do you remember?
Consecutive sides?
Consecutive sides are congruent. So this one, consecutive with this one is congruent, and then separately, these 2 are congruent. Did any of you get all 3 of them? Good work, guys. Good work, good work. Again, this is stuff you would want to review before we quiz or test all these properties. Okay, let's go to the next one. Okay, this one, you're looking at the picture and you're identifying what kind of quadrilateral it is, what kind of special quadrilateral. You always want to give the most specific classification. You ready? Try them on your own. Go. All right, nice and confident. Number 1 is definitely a rhombus. Way to be confident. Number 2 is definitely a rectangle. Good work. Number 3? Isosceles. I agree with trapezoid. Be more specific and add one word. What is it? Isosceles. Good work. If you don't have that, will you add that in there? It's totally isosceles. Those legs are congruent to each other. Okay. 3 new shapes. Right here. The tricky thing is the diagonals are not congruent. Can you think of 3 shapes that have diagonals that are not congruent? However, not just a shape. It's got to be a quadrilateral. It has to have 4 sides. Good luck. Sketch it out. I are some great discussions. What if we go backwards from this verse? Can anybody name a shape that does have congruent diagonals? Ali, you've got one? Rectangle. Okay, so make a rectangle. Like the old school, like this. Can you do that? Making a rectangle. If you look at the diagonals. Guys, do you think they would be forced to be congruent? They'd always have to be because it's the same point to the same point, right? Alright, so can anybody give me one that does not have congruent diagonals? Taya? Kite, absolutely. Because you've got one that's really long, right? And then one that's shorter. I don't remember which one I put that under. Does anybody have another shape? Not congruent? Tyler, you got one? Rhombus? Yes, because one is barely shorter than the other because it's squashy. Callie?
A trapezoid that's not isosceles.
Oh, perfect. She said a trapezoid that's not isosceles. If it was isosceles, they would be congruent. Okay, there's a trapezoid, that's Callie's. Can't be isosceles though. So diagonals they're talking about from this to this, long, this to this, shorter. They're not the same. Okay, this one. I got that one. One's definitely longer than the other. Okay, you ready for this one? Parallelogram like this, I would say your diagonals are never congruent. One's going to be barely longer than the other. However, is it a tiny bit dangerous to say parallelogram? Because what else is a parallelogram but their diagonals are congruent? Square, what else? Rectangle, what else? Anything? Square, rectangle, I think that handles it, right? But if it's a parallelogram like this, then that wouldn't work. One's longer than the other. How do you know, does that make sense? You okay with that? Again, all these attributes of our quadrilaterals. Okay, this one, again, this is what I'm telling you with the CRT. I think people are just like tired of taking this big long math test. They're like, yeah, it looks like this. But make sure you prove what it is. Okay, just like on the warm-up, this is a trapezoid. However, look, what kind of trapezoid is it? It's isosceles. So we have to use slope and distance formula. I think you have a whole page in your notes dedicated to this problem. Is that true? Yeah. So if you want to fill in those blanks, you're more than welcome to. If you want to use the column down the side, you can do that also, whatever you feel like. I like to draw on the pictures. Let's do slope like Ali did first on the trapezoid. So it looks like this one is parallel to this one. So let's count it out and prove it. So from Q to R, oh stop. Do you remember what I've been telling you why students might miss this one if they rush through these problems? I always get nervous and I always check this before I do anything. Do you remember? I said it like 3 times. Do you remember, Tyler? Sometimes they go by twos. Be careful. Does this one go by twos? Whew, sometimes they will. Though. Just watch for it. So from Q to R, we go up 1, 2, over 1, 2. Perfect. So the slope of QR is 2 over 2. Or you can think of it as just 1 over 1, which is just 1. Okay, the slope of TS, so from T to S, up 1, 2, 3, 4, 5, over 1, 2, 3, 4, 5. Convenient. Okay, so can we say that these ones are parallel? They're exactly the same, so they'd be forced to be parallel. Okay, unfortunately, are we done? No, because we've now shown that it's a trapezoid. One pair of opposite sides is parallel. Since it's isosceles, we have to show those legs equal each other. So let me erase what I've written on our picture. And let's do the slope formula together. Because I'm going to use Q as my first coordinate, so my x1 and my y1, and my t as my second coordinate, so x2 and y2. If you can't remember a distance, I'll write it up here for you. It might already be on your notes. I can't remember if I put it in there. So subtract your x coordinates and then square them and then add them to your y. The difference of the y's and then square. Okay. Again, I like to label them so I don't mess this up. So x2 minus x1, 3 minus 2. Don't forget to square it. Plus y2 minus y1, 1 minus 5. Again, don't forget to square it. Okay, 3 minus 2, negative 1, right? Negative 1 times negative 1 is a positive 1. Plus 1 minus 5 is negative 4. Negative 4 times negative 4 is a positive 16. Let's just leave it as this radical 17. I'm okay with that. Okay, so what we just found is the length of this leg is the square root of 17. If it's isosceles, what should the length of this one be? Exactly. exactly the same, so let's hope it works out that way. So I'm going to use R as my first coordinate and S as my second coordinate and go through the exact same motions. So the distance formula for RS would be 8 minus 4 square root plus 6 minus 7 squared. Alright, I think we're sitting good. 8 minus 4 is just 4. 4 times 4 is 16. Plus 6 minus 7, negative 1. Negative 1 times negative 1, positive 1. Alright, oh, that was kind of wonky. Square root of 17, that's what we wanted. So we just showed that square root of 17. Legs are congruent, opposite. One pair of opposite sides is parallel. So it took some time, right? But how many of you, I've got it. Even though it takes time, does this make sense? Don't give up on these on the CRT. Take your time on it. Okay, let's see what's next. Oh, this one. Okay, what type of quadrilateral is ABCD? Think about it first and write down what you think. All right, whisper to a neighbor, tell it would be. Okay, let's go over it, because I just took a picture of exactly what your notes said. This one is actually kind of convenient that they lead us into it. Do you have the little bubble off to the side? Oh, you do. So right here, you can use the alternate interior angles converse to show that this side is parallel to this side. Why? Because this angle is congruent to that angle. So it's a transversal cutting through. Remember that one chapter? So that's parallel to that. And then vice versa, we can say that this is parallel to this because of alternate interior angles. Again, this one congruent to that one. Okay, so now we know at least this much. Do you agree? Using alternate interior angles, we can say it's a parallelogram. Both pairs of opposite angles, opposite sides are parallel. Okay, and then this, it's been since last week. Last week we learned this. The diagonals and rhombuses bisect opposite angles. So those angles are getting cut perfectly in half. That happens in what kind of shape? A rhombus. Okay, well, number 5 is stretching you a little bit. So, could we say that picture is a square? Do you think the diagonals get bisected in squares? Yes, they do. Can we say that shape is a square then? I'm hearing yeses, and I'm seeing people shake their head no. I want to hear a no defend themselves. Want to defend themselves? Go ahead, Kelly.
Because a square is a rectangle and a rhombus, and we can prove it's a rhombus, but we can't prove it's a rectangle.
Check. I agree with her. Let me repeat it in the mic. She said a square is a rhombus and a rectangle. We can prove that it's a rhombus, because it is, right? Can we prove it's a rectangle? What's missing? What do we not know in this picture? Yes, yes, yes. We don't know 90-degree angles. Do you agree with us? So this one I would say not enough info. If we could prove that they were 90-degree angles, then we could say it was a square. But we can't. We don't have enough information to. Okay, last one. One more example of that. Oh, and we have to say what type it is? Okay, well, be nice to yourself. Look at it. What type does it look like at least? Rectangle? Anything else that it could be? Trapezoid? Maybe. We'd have to check slopes, right? So rectangle, trapezoid, square? Rhombus? Alright, so let's go through this. Think about it. I'm kind of leaning towards rectangle. How many of you are with me? They kind of look pretty straight to me. Let's check the slopes. Now, we've talked about parallel slopes, right? They have to be exactly the same. It's been a while. Do you remember how to tell if two slopes are perpendicular? Yes, something about reciprocals, but there's one more thing you have to add, Jaden. Do you remember? Negative reciprocals. Okay, guys, I'm just totally making this up. This doesn't have to do with the picture yet. Let's go over this concept real fast. If you had a slope of 2/3, do you remember what its perpendicular slope would be? Perfect. Flip it and make it negative. -3/2. That means those two make 90-degree angles. Let's do one more. No, let's do two more. If you had -5/6, what would its perpendicular slope be? Okay, one more. What if you had just 7? Perfect, perfect, perfect. Okay, keep that in mind because can we just check all slopes? And then they should show that they're perpendicular if it's a rectangle. Okay, let's do it. So let's find the slope of this one and this one. Show they're the same, they're parallel. So A to B. Oh, stop, check. Good, counts by ones. All right, 1, 2, 3, 4, 5 by 1, 2, 3, 4. Perfect. All right, that one's 5 by 5. This one, D to C, 1, 2, 3, 4, 5. 1, 2, 3, 4. Perfect. Okay. AB was the same as DC. They were both 5, 5, so they're parallel. Remember that doesn't mean, I'm not using that for 11, I'm using that for the simple parallel. Okay, let's show for AD. So AD down 1, 2, 3, 4 over 1, 2, 3, 4. Right, down 4 over 4. Same thing, B to C, 1, 2, 3, 4. 1, 2, 3, 4. Down 4 over 4. Okay, so they're the same. So is that enough info to say they're also perpendicular? Okay, we could do the distance formula. We could show they're exactly the same. Right here, simplify this. 5 over 5 is really just 1. Could I put it as 1 over 1? You okay with that? Still 1. Simplify this one. What do you think? Can we say those are perpendicular? It's the negative reciprocal of each other, right? I'd say we have enough info to say that is a rectangle. Is that the only way to prove it? Absolutely not. You can use the distance formula and show the two sides are congruent to each other, but you probably have to come back to slope and show 90